Hello everyone, my name is Rohit, and today I'm going to present how Apache Handlooms enables large organizations to build enterprises-grade data lakes. In this session, I will first introduce the concept of data lakes and then walk you through the complete architecture of Handlooms powers data lakes, highlighting all the key components, technical layers, and real-world scenarios. Let's start by understanding what data lake is. A data lake is a centralized repository that allows you to store all types of data structured, semi-structured, and unstructured at any scale. Unlike traditional data warehouse, data lakes use a scheme on read approach, which means the data is stored in raw format and structured only when it's read or analyzed. This is a game changer in the enterprise environments because modern business generate huge volumes of diverse data, including images, sensors, clickstreams, and more. Data lakes are crucial for AI, machine learning, business analytics, and real-time decision making. They enable organizations to move away from expensive ELT pipelines and rigid schemes, offering scalability, flexibility, and cost effectively. Slide 3. Why Hadoop for data lakes? Why is Apache Hadoops the foundation of the most data lakes? Because it provides massive scalability through HDFS, distributed processing through MapReduce and Spark, cluster resource management through YARN, security and metadata governance through Ranger and Atlas. Hadoop's open source ecosystem support high throughput data ingestion, batch and real-time processing. SQL-like querying and access control everything you need for building a data lake. Slide 4. Now let's walk through the complete architecture of a Hadoop-based data lake, which includes 6 key layers. Number 1. Ingestion layer. Tools like Scoop, Few, and Kafka are used to bring in the data from multiple sources such as relational database, IoT devices, social media, and logs. Storage layer HDFS stores a large volume of structured, semi-structured, and unstructured data with redundancy and fault tolerance. Number 3. Processing layer includes MapReduce for batch processing, Apache Spark for in-memory processing, and Hive for SQL-like queries. Number 4. Resource management layer. YARN coordinates distributed computing resources. Metadata and governance layer. Apache Atlas manages data and metadata, while Apache Rangers enforces the access control. Number 6. Access layer. Tools like Hive, Presto, and Spark MLLIB are used by analysts, data analysts, data scientists, and business users. Let's now go deeper into each major component. Apache Flume captures log data from distributed servers. Apache Scoop is used to transfer data between Hadoop and relational databases. Kafka handles real-time event streaming for ingestion. HDFS is a foundational storage system. It breaks files into blocks and distributes them across nodes in a cluster. Hive allows users to run SQL queries on top of Hadoop data using HiveQL. Apache Spark provides faster in-memory computations and supports advanced analytics and machine learning workloads. Atlas enables metadata management, data lineage, and audit trials. Ranger forces centralized security, administration, and policies. Here is a visual representation of layered architectures we just discussed. On the left, data flows in from multiple sources. The data is ingested into HDFS via ingestion tool, processed using Spark and Hive, and then queried or analyzed by various users through the access layer. Atlas and ranges cut across the system to ensure data integrity, security, and traceability. This diagram reflects the end-to-end pipeline from raw data to usable insights within an enterprise data lake powered by Hadoop. So let's go to real world use cases. Hadoop powered data lakes are used at many top tech companies. Netflix uses a Hadoop based pipeline to handle the billions of daily events. Facebook performs petabyte scale analytics to personalize your user feeds. LinkedIn uses Handoops and Spark power its recommendation engines and fraud detection. These organizations benefit from the scalability, flexibility, and deep integrations of Hadoop components in their data workflows. To summarize, a data lake provides centralized, scalable storage for diverse data types. Apache Handoops enables this through HDFS, Yarn, MapReduce Spark, Hive, and governance tools. Its open source ecosystem makes it suitable for both batch and real-time analytics at enterprise scale. Organizations using the Handoops for their data lakes gains operational flexibility, insights-driven decision making. Flowchart: Data movement in Hadoop data lake. This flowchart shows a typical data flow in a Hadoop-based data lake. On the left are the data sources, databases, real-time streaming apps, and log files. These are ingested via Kafka, Flume, or Scoop. The data is stored in HDFS, processed via Spark or Hive, and accessed for analysis or machine learning use. This flow ensures high throughput, low latency data movement in enterprise environment. I hope this walkthrough helped you understand not only the architecture but also the practical application of Handoops in data lake environments. If you have any questions, feel free to reach out.